Hey everyone, in this video I'm going to discuss about matrix. What is matrix? What are the different types of matrices, and what is a determinant, and how to find 4 by 4 determinant, and these kind of things I'm going to discuss. Later I cover how matrices is going to be useful in the deep learning, and those kind of videos will create later. So first we'll understand what is a matrix. Matrix means arrangement of elements in rows and columns. So you have some elements like 1, 2, 3, 4, 5, 6, 7, 8, 9, and something like that. So if you arrange those elements in rows and columns, then that is nothing but a matrix. Uh, so this is one horizontally. If you arrange the elements, then that's nothing but a row. If you arrange the things in a vertically, then that is nothing but a column. So this is a 2 by 2 matrix. How I'm saying this, it has a two rows and two columns. So it is 2 by 2. So we indicates the matrix in terms of m rows and n columns. We call it as a m by n matrix. So it's not only be a 2 by 2 matrix, like we can declare the matrix in 3 by 3 also, like 1, 2, 3, uh, 4, 5, 6. Okay, let's take this matrix only. So if what is the order of this is, like it is a two rows and three columns, it is 2 by 3 matrix. So what this indicates, like, see, if you multiply these things, you will get the number of elements available in that matrix. If you multiply these things, you will get 6. So the total 6 elements are there. If you multiply this, you will get 4. So total 4 elements are there. So we'll use GPT-4 to discuss these definitions and how it's going to be useful. So let's understand. So I already told you what is a matrix. Matrix is arrangement of elements in rows and columns, and so different types of matrices are available. So one is symmetric matrix, and so before going to symmetrics or non-symmetric matrix, you have to understand what is the transpose of a matrix and how these things are going to be useful. So in a practical scenario, so everyone has a mobile phone and they'll take the pictures and they'll do some basic operations like rotating the image, or you know um, doing some image operations. So at that time, in the background, matrices are working. So you have some image, so it is converted in the form of pixels, like 0 to 255. Those things are presented in terms of rows and columns, that is arranged in terms of a matrix only. So if you do some 90 degrees rotation, so this picture will turn like this and left and right. So these things are happening based on the matrices only. So that is one practical example. So there are many applications associated with matrices. So here my this is the recording I'm doing for just my own reference. I'm not so go I'm not giving any gyan. uh, so the symmetric matrix is nothing but, if you have one matrix, if you transpose the matrix, transpose means if you change the rows into columns or columns into rows, then that is nothing but a transpose. So in this example, you can see this is the original matrix. Transpose means what? So you're converting the row into column, column into row. So 1 3 is converted into in this way, and 2 4 is converted in this way. So that is nothing but a transpose of a matrix. If the original matrix is equal to transpose of the matrix, then it is a symmetric matrix. So this is the example. So 1 2 2 3. So the if you transpose this matrix, you'll get the same thing. So that's why we're indicating it as a symmetric matrix. There are multiple things are involved in this thing. So you have to understand about arbitrary elements. What is arbitrary elements means, in this position, this is known as diagonal. 1 3, these things is known as diagonal. So this thing is this diagonal, you can do whatever you want to give. You can give whatever you want to give. And if you see, this is the position where we consider it as a lower triangular matrix. Lower triangle means the elements which are present above the diagonal, then is known as lower triangular matrix. So in this case, it is a 2 by 2 matrix. So this is only example. Whatever element is there, value is there, that will be present in this, diagonally, this element also same. So that is the asymmetric matrix. If you observe any 3 by 3 matrix, you will get the much more clarity. Then skew symmetric matrix is, if you have one matrix, and if you transpose that, it is equal to negative of the transpose, then it is a skew symmetric. The best part is like, the sum of the elements in a skew symmetric matrix is zero. So if you totally sum these things, we'll get the zero only. And one more thing is the diagonal elements has to be zero. So consider this example. In this 2 by 2 matrix, you have this thing is known as the diagonal elements. These things has to be zero, and if you sum all the elements inside that matrix, it's going to be zero. So that is a point of skew symmetric matrix. And orthogonal matrix. Orthogonal matrix means if you have some A, and you transpose that, the product of A and A transpose equal to A transpose into A, that is equal to I. I means identity matrix. So so what is identity matrix means, if you have 1 0 0 1, this is an identity matrix in the form of 2 by 2. If you want to go with the 3 by 3, then you have to put 0 here, 0 here, then 0 0 1. This is a 3 by 3 matrix of identity matrix. Okay. So what my point is, like, you have some matrix as A. So if you multiply that with the transpose of the same matrix, then, or it is equal to A transpose into A. Or if you have the transpose of a matrix, if you multiply that with the original matrix, if it is equal to I, these things are equal to identity matrix, then if this condition happens, then A transpose equal to A inverse. So this property is very very helpful in order to find the inverse of a matrix. Inverse of a matrix. See, they'll give you one matrix. They'll ask you to find, inverse of a matrix. If it is a 2 by 2, the straightforward formula is there. One by, so A inverse equal to adjoint A by det A. That is the basic formula of A inverse. So we have one. If you have one matrix, they'll ask you to find the, inverse of that matrix, then the formula is A inverse equal to adjoint A by adjoint A by det A. Okay, so we don't need to worry about A inverse, and we'll discuss in the later sections. And so, ultimate point is like, if you identify the matrix as an orthogonal matrix, then someone asks you to find the inverse of that matrix, then obviously, simply you can transpose that matrix, that is inverse of that orthogonal matrix. So this part is done. Then we'll discuss about determinant, how to find the determinant of a matrix, how to find the 4 by 4 uh, of a matrix. We'll discuss that. Okay, let me take one image. First we'll discuss this orthogonal. Mhm. Okay, first let me just clear this frame, and I'll insert one image. See, first, we'll discuss about what is orthogonal. We already covered what is orthogonal matrix. It's one of the type of the matrix, and they'll give some problems like this. They'll ask you to find the inverse of that matrix, or they'll give some like questions kind of like this, and they'll find you. They'll ask you to find these kind of variables and etc. So there are two important properties related to orthogonal matrix. So first thing is like, if you sum of the square of the any row of that orthogonal matrix is equal to 1. So in this example, you can see it's a 3 by 7, 2 by 7, 6 by 7. So sum of the squares of the any row is equal to 1. Uh, So 3 by 7 whole square plus 2 by 7 whole square plus 6 by 7 whole square. So denominator will get 49. So 9 plus 4 plus 36. So total 49. 49 by 49 1. So this condition is satisfied. So another condition is sum of the product of any two different rows equal to 0. So so that means if you sum of the products of two different rows, see this one, so minus 6 by 7 into 2 by 7 plus 3 by 7 into x plus 2 by 7 into minus 3 by 7, so that is equal to 0. So if you done this operation, so you'll get the value. So this is one of the property. Based on these property, you can solve many interesting problems related to orthogonal matrix. Then this is sorted. Discuss about determinant. See, they'll give you one matrix and they'll ask you to find the determinant of that matrix. There are many ways to find the determinant. Like if it is a 2 by 2 matrix, it's a very simple. I'll give you. I'll do this thing here. So let's assume. So they ask you to find the determinant of this one. So one, two, three, four. So simply you can consider this as A, B, C, D. So the formula is AD minus BC. So here 1 into 4, so 4 minus 6. So answer is minus 2. So this is the determinant of 2 by 2 matrix. So 3 by 3 matrix also I can tell you, 4 by 4 matrix also I will tell you. So how to find the determinant of the 4 by 4 and 3 by 3. So so in this example you can see, first, I'll tell you 3 by 3 matrix. Don't consider these things. So just consider this minus 2, 1, 3, 2 minus 1, 0, minus 2, 3, 4. They'll ask you to find the 3 by 3 matrix determinant. So how to find this one? So first you have to select the first element of the first row. So that is minus 2. And you have to, there is one thing. So that is nothing but minors and cofactors. Those things you have to understand. Otherwise, one element is there. So let's assume, so this is the first row, first element, first row, second element, first row, third element. It is known as A11. It was indicated as A11. So this is indicated as A12. So this is indicated as A13. In the same way, this is A21, A22, A23, A31, A32, A33. So so if you so you have to multiply. So the formula is like simply, so you have to sum of this to minus 1 whole power minus 1 whole power. So whatever this I value and j value is there now, so you have to sum those things in the product, a power of this one into, you have to do the 2 by 2 matrix here. So so remove this one and this one. So whatever you got, place it here. So minus 1, 0, 3, 4. If you solve this one, so obviously minus 1 whole power is like positive only. So positive, that's why we give it as a plus. And so 4 minus 1 is minus 4. This is AD minus BC formula only. So minus 4 minus 0. So it's obviously minus 4. So that's why we got the minus 4. Here you have to multiply this with the whatever value which was there. No? So we have to multiply that with this value. So we have obviously have minus 2 here earlier. So that's why minus 2 into, so this one minus 2 into whatever value you got. So you have to you got minus 4, so you have to add minus 4. So that's it. So in this way you have to I'll explain this one example so that we'll get the clarity. So simply you can do like this, and you can get minus 2 into so AD minus BC minus 4, and after that if you apply this one, so minus 1 whole power 1 plus 2, so that is nothing but minus. That's why we added the minus sign here. So this is the existent element here, so 1 already here. Then after that you can do like this. So whatever you got, so 2 0 minus 2 4, so 4 2s are 8 minus 0, so 8. Then so you get the same thing. Then you have to, so this is a 1 3. So obviously if you sum that one, minus 1 whole power 1 plus 3, that becomes plus only. So plus, and so this is the value which was there. So 3 into, you can do like this. So 3 into 6, minus of minus, minus of minus plus, and so already minus was there, so that's why 6 minus 2. So this is the value you got if you do the 3 by 3 matrix. So it is 12. So now I'll tell you how to do the 4 by 4 matrix. So you can apply the same thing in 5 by 5 whatever matrix they given to you. So first thing you have to identify is you have to figure out, you have to select one element, and the corresponding row or corresponding column, three element has to be zero. You have to make the adjustment like that. So you can do column operations, you can do row operations. Like in this examples I done, this is the first column, second column, third column, and fourth column. I identified this element. Why? Because already two zeros are there in this entire row. So if I make this element as zero, then my process become very easier. So that's why I selected this. And so what I done the column operation here. So C4, my intention is I want to make this element as zero, so that my process become much more easier. And you know so what I done this, I perform this column operation. So C4 tends to C4 minus 3 C1. Why I done this step? So because this is a column, I want to make this element as zero. So C4 minus 3 into C1. So C1 is this column, so 3 minus 3 obviously will become 0. So once I done this step, so it will become like this. So 1 0 0 0, and you have to perform this also. Okay, so minus 1 1, this is common, this is common, this is common. After that you have to apply this logic here to the entire column. So once you enter this column, so these are the updated values. Once you got these updated values, you have to make sure, like whatever row you selected, like whatever the element you selected, you have to do like this. See in this example, you done like this, the same steps like plus minus. So you can remember this thing as one more in another way also. Obviously the first one start with plus, and next alternative is minus plus minus. In that way the alternative signs will change. So then you done like this, and after that you take the, this is nothing but a 3 by 3 matrix, right? So take this one, so do the 3 by 3 matrix, you will get this value. So that's it. So you can get, in this way you can solve the 4 by 4 matrix, 2 by 2 matrix, 3 by 3 matrix, anything, 5 by 5 also. So I think we covered matrix, different type of matrix, and determinants, and orthogonal matrix. So next I think we can cover rank, and A inverse, and after that system of linear equations, and after that Cayley Hamilton, after that eigenvalues, eigenvectors, then LU decomposition. So these kind of things will cover. So before closing this, I'll just mention this. So singular matrix means you already solved determinant. So if the determinant value is equal to zero, then it is a singular matrix. If the determinant value is not equal to zero, it was any scalar or any number will came, so then that is a non-singular matrix. So that's it. I hope it'll make some sense.